Determine the resultant force at A. So we need to add FB and FC together. So we need to get the vectors of each of those and then add the components. So we'll start by getting the position vector of B. And so the position vector, it goes in the x direction. It looks like it goes from there to there, so a -2 in the I. And it goes in the y, it goes from here to there, so 4 in the j. And in the z, it drops from 6 feet down to 2 feet, so -4 in the k. So the magnitude of B is the square root of 2 squared plus 4 squared plus 4 squared. And that equals 6. So the unit vector of B is the vector divided by the magnitude. So -2 6 in the I plus 4 6 in the j minus 4 6 in the k. And now we could reduce that, but since our force is actually 600, that would be extra work. So the force B is the magnitude of force times the unit vector. And so now we have a force of 600 pounds times the unit vector -2 6 I plus 4 6 j minus 4 6 k gives us a force vector of -200 in the I plus 400 in the j minus 400 in the k, and that is all in pounds. Now let's do C. So the position vector of C is, in the x, it goes all the way over 6. -6 in the I. And the j, it comes out 3. And in the k, it drops from 6 to 4, so -2. And the magnitude of PC is the square root of 6 squared plus 3 squared plus 2 squared, and that equals 7. The unit vector, this divided by 7, okay, and the force vector, the magnitude times the unit vector, and the magnitude is 490. Again, that's nice because it's a multiple of 7. And the force equals -420